Before the telephone was invented, people communicated through the mail. After its invention in the mid-19th century, people started to transmit analog signals along metal wires. A century later, fiber optic technology has been developed and optical fibers have overtaken metal wires for digital signal transmission. Where did these digital signals come from? Postcode modulation technology, or PCM technology, generates digital signals by sampling, quantifying, and encoding analog signals. PCM technology is widely used in power, railway, urban rail transit, and energy transmission systems. PCM technology has progressed so far that PCM equipment can now access beyond voice services to multiple low-speed data services. In the power system, supervisory and dispatch signals from power plants as well as emergency dispatch, teleprotection, sensing, supervisory, and RTU signals from substations all require PCM equipment for network access. These signals are then transmitted over the communications transmission network to the dispatch center. In the railway system, order wire, emergency dispatch, and other low-speed services, including supervisory and tetra signals of the railway stations, all require PCM equipment for network access. In the urban rail transit system, order wire, emergency dispatch, and other low-speed services, including supervisory, TV control, time system, broadcast system, and tetra signals all require PCM equipment for network access. In the enterprise network, PCM equipment is required for access by different services. However, this use of PCM equipment has the following disadvantages: space-consuming and costly. Different PCM devices are required for access by the different emergency dispatch, office phone, teleprotection, supervisory and sensing signals, and RTU services. These stacks of multiple PCM devices take up space and increase investment costs. Low reliability. Service cascading is required to send different service signals to the transmission network through different PCM devices. This reduces network reliability while making network connectivity even more complicated. O&M difficulties. Enterprise network PCM devices can be varied and must undergo individual service configuration, provisioning, and management. Any fault that occurs cannot be easily traced back to a specific PCM device. HUAWEI solution integrates the PCM module with an MSTP device for the following advantages: space-saving and cost-effective. This solution of a PCM board on an MSTP device provides the same access of various low-speed PCM services as PCM equipment, but requires less space and investment costs. High reliability. Since a single PCM board is used to send different service signals to the transmission network, service cascading is no longer required. This improves network reliability while simplifying connectivity. Easier O&M. The centralized NMS manages PCM boards and other MSTP components. Services can be configured and provisioned directly on the NMC. In addition, the viewable O&M function of the HUAWEI NMS makes network performance visible and observable. An FXSO12 board provides 12 FXS/FXO ports for voice analog signal access. An AT6 board provides 6 2 or 4 wild audio ENM signaling ports for voice service or signaling access. By collaborating with a DM12 interface board, an N3DX1 board provides multiple PCM service access.